Our next unit is about ratios, proportions, and percents, some of the most commonly used math in everyday life, no matter who you are. The idea of a ratio is simply a comparison of numbers. And to be mathematically correct, I should also say using division. But just let's keep it simple and call it a comparison of numbers. For example, if I say the ratio of boys to girls in a particular class, if I count the number of boys, let's say it is 6, and I count the number of girls, then the ratio of boys to girls, and boys has to go first and girls would have to go second, if I'm doing it like that, is 6 to 8. The two other ways to write that are 6 to 8 or 6 to 8. Notice when you see it in a fraction, it's easy to realize that you also, just like fractions, ratios must be simplified. In other words, reduced to lowest terms. So in this situation, this would be a ratio of 3 to 4. Notice also that neither the boys or the girls is the whole class. So this is considered a part-to-part ratio, because neither one is the whole class. If I wanted to say the ratio, the fraction of boys in the class, I would have to say the part that is boys out of the whole thing, and this would be considered a part-to-whole ratio. And these are really what fractions, decimals, percents are all based on the notion of part to whole. And again, we would have to simplify that. 3 is to 7. That comes up in ratios is that sometimes things aren't in the same unit. If I say 3 days to 2 weeks, before I can even simplify them, I have to put them in the same denomination. Since weeks is made up by a bunch of days, I change this to 3 days to 14 days, because 2 weeks is 14 days, so I would say 3 to 14. If I say 6 inches to, 3 feet, I would say 6 inches, and since every foot is 12, 3 times 12 is to 36, and I would reduce that, and that would be 1 to 6. I know that you have been reviewing the metric system in science, and that's really handy for ERBs. If I say 6 meters to, 30 centimeters, 6 meters, as we know, since there are 100 centimeters, would be 600 centimeters to 30, and that would give me a ratio, 60 divided by 3 is 20, 20 to 1. Notice, when everything cancels out, you need the 1 in a ratio. Today, we said that the cars in a lot were in a ratio of 5 to 2. Notice this is a part-to-part ratio, cars to trucks. And we know that the lot holds a total of 84 cars. Well, we went around in different ways to do this, but one way to think about this is that 5 parts out of 7, if I say 5 out of 7, is how many out of 84? And since 7 times 12 is 84, just using our notion of equal fractions, that means that there would be 60 cars out of a total. This is an example of a proportion. Proportions are equal ratios. which really ends up being just the same idea as equal fractions. I can do this because if I'm multiplying the top and the bottom by the same number, I'm really multiplying by 12 over 12, which is equal to 1. So 60 out of 84 is just a different number for 5/7. They represent the same quantity. If I take any two equal fractions, let's say 2/3 is 4/6, we know this because you have done enough math. Anytime that's true, if I do this cross multiplication, 2 times 6 will always equal 3 times 4. In other words, if I have A over B is equal to C over D, then A times D will always equal B times C. That has a name. It is called the law of proportions. I'm out of room, and it's not really important. Proportions. The reason why it is important is to solve when we don't know exactly what a quantity is. If I go back to the car problem, 5 out of 7 is equal to some number, we're going to use our variable there, out of 84. Using a calculator, I can, in this case, it's probably easiest just to notice that it's multiplied by 12, but if I say 5 times 84, and then that equals 7 times some number, well, 5 times 84, that's a little bit hard to do quickly. Let's see what 5 times 84 is. 5 times 84 is 420. 420 is equal to 7 times some number, which means that 420 divided by 7 will give us our number. If 7 times some number is 420, then 420 divided by 7, and therefore I can see it's 60. So all you have to do is enter into your calculator the two things that you see. In this case, it's 5 times 84, and I do want you to use a calculator. And then you put equals, that will give you 420, and then you divide by the other number, is equal to 60. So let's it's just like that. And they can be, things with decimals. So let's just say 20 is to 8.7 and that's how you read these proportions. 5.8 is to some number. So again, in our calculators, we say the two numbers that we have are 5.8 and 8.7. So 5.8 times 8.7 equals 50.46. So 5.8 times 8.7 is 50.46. And now I take that number and I divide it by 20. Divided by 20 equals 2.523. And I think here they probably are rounding. 2.523. Okay, well, let's do one more. That's 5 is to 16 as 11 is to y. And notice this could be 5 is to 16 as 11 is to y. But it's easiest to solve them like this. Here are the two numbers that we have. So we're going to say 16 times 11 equals 16 times 11 equals 176. And we're going to take that number and we're going to divide it by 5. Divided by 5 equals 35.2. And that's how you solve proportions. I think that that's enough for you to be able to do your homework tonight, but remember, these are really basic and important concepts in math.